All right, here we go. Hi, with Alec, Philip Johnston, Starcloud co-founder and CEO. I promise you what I'm about to say about this guy and this company is 100% true. They are launching data centers into outer space. And I remember when I first read that, I don't know where, it might have been one of your white papers, Philip, but I was absolutely unequivocally blown away, stoked. And I think I just reached out to you directly on LinkedIn and was like, hey, can I interview you? Let's do something. And you were kind enough to say, yes, give me a little bit of time and we'll make it happen. And here we are. So without further delay, Philip, so good to have you here with the AI with Alec community. I know we're going to geek out. Give us something. Give us some origin stuff. Give us like, how did you come up with the idea? What problem are you solving? Like, let's go.
I mean, thanks so much for having me. I always like geeking out, so I appreciate you reaching out.
We're here. We're here.
Origin story is, I mean, my background, I'm more on the commercial side. I had also founded and sold another company in between. And then I'd spent time working at the space agencies of various companies, various governments in the Middle East with McKinsey and Company, a consulting firm. And then so I'd seen from that period that the launch cost was coming down very rapidly. And I'm interested in space in general. So I've been thinking like, what would very low cost launch enable? And in 2023, about May, just before the first launch, I went down to Starbase, Texas. I happened to be in the US and I was like, am I allowed to swear on this thing? Can I say?
I think I thought you were going to go there and I was like, yeah, go for it. See what happens.
I had a week and I was like, I'm going to go down to see like this thing. Like it was like the most insane, ambitious goal that they were building, this fully reusable rocket. I think it's like 3 times the thrust of any other rocket before. It's a payload bay is like 5 times the payload of a Falcon 9, which is the current workhorse. So it's just absolutely massive. So I was like, okay, I'm going to go see this thing. And what struck me about being there is not just that they're building this ambitious rocket, but the capacity they're planning for is absolutely insane. So they're building these 2 Starship gigafactories, one in Florida, one in South Texas. They're saying they can roll within 18 months. They'll have 3 Starships a week coming off that production line. It's basically like a Tesla gigafactory for Starships. And within 36 months, so in 3 years, they'll be having 3 Starships a day coming off that production line. And each Starship can fly 3 times a day, potentially, depending you believe. Each one can put 100 to 200 tons of payload to orbit. I mean, the amount of capacity that we're going to have is launch cost could come down by X, capacity could go up by 10,000x, just because you can keep reflying these things. So that's my co-founder Ezra. We're from the same place in the UK. So I got in touch with him. I was like, what would be? He's a space engineer. He spent the last decade designing satellites with us Defense and Space and others. He has a PhD in engineering. So I was like, what would be enabled by low-cost launch? And one of the first things we were looking at was space-based solar. So there's a sort of concept from the 70s where you have very large solar panels and then you use some kind of technology to get that power down. Usually people talk about microwave technology, so you're beaming the power down with microwaves. And that's an issue what we're looking at. And we were thinking, okay, what are we going to use this power for once we get it down? And the forecasts are, I think, in 20 years' time, half of all terrestrial electricity consumption will go into data centers. So, like, okay, we'll use it for data centers because that seems like a good market for it. The problem is you have like 95% energy loss or efficiency loss from space to Earth. For every 100 watts you're collecting in space, you're only getting 5 watts down usable on Earth. And so the next logical thing we're thinking of, well, if you can find a cheap way to get the data center to space, does it make sense to do that? And that's where the origin of the white paper came, was us looking at the calculations for what's the mass of data center, what does the launch cost have to be for that to be economical? And it turns out that if your launch cost gets below around $400 a kilo, then it's a good deal. And if it goes much below that, then it's a complete inevitability. So, I mean, the marginal launch cost that they're talking about with Starship is $10 a kilo. So that's like how much additional it will cost Starship for an additional launch. So it's potential. I mean, if we go down to $100 a kilo, we're a very good business. If we go down to $20 a kilo, we're like an extremely profitable business. So that's really where we're playing towards, is building these extremely large data centers in space, purely from an energy perspective.
It's amazing. So my audience, I know, is very into this dimension of thought, and just let's speak to this for a second, right? So you just touched on the concerns about powering data centers if, quote unquote, nothing changes other than the trajectory of our consumption and use of artificial intelligence, for example. Can you paint that picture a little bit further and more? Because I think most people kind of like, they hear that and they're like, oh, that makes sense. But like, I think it'd be good to hear it from you a little bit further into how big is that problem, and therefore how significant is this opportunity if and when it all works out the way that I'm sure it will for you guys?
Yeah, I mean, we're on this absolutely insane exponential growth curve now in terms of power consumption needed for running AI data centers, or data centers in general, but particularly for the latest inference data centers. So I think let's say we have 100 gigawatts of total data center capacity right now. Within 5 years that could be 500 gigawatts, for example. And there just isn't that amount of. We just don't have the energy to do that right now. So we're going to need to build enormous new energy projects in order to be able to service these things. And like on a 5-year time frame, that's doable. On a 10-year time frame, that's doable. But there comes a point where if we have, let's say, 100 times more data center need than we currently have, and that might be on a 20-year time frame, then there's just literally no way you can get 100 times the amount of power that we currently have from the grid. The amount of like nuclear projects you'd need to build that, the amount of build enormous solar projects for that. And the real constraint is actually the lead time on the permitting, which I know sounds like a silly thing to be the constraint, but if you want to build a new nuclear project, for example, and by the way, nuclear isn't even that cheap. It's like 8 cents per kilowatt hour for a new nuclear project. But if you want to do that, the lead time on permitting is like 10 to 20 years currently. The best you can do is maybe get that down to 5 years, but it's extremely long lead time. Whereas with what we're doing, potentially within a month, you can launch a 40 megawatt data center. There's basically no limit to the amount of these things you could put in orbit, and you could do it very quickly. That's the real reason we're doing what we're doing.
It's amazing. And correct me if I'm wrong, I think I read in The Economist that recent article, and congrats on the coverage and all sorts of stuff, of late. So
Thanks
I'm not surprised at all. But is it right that you're doing something in May, right? Coming up here with a refrigerator sized, am I remembering this correctly? Data center, like this is a big deal, right?
Yeah, we're launching our first demonstrator satellite. The launch window is May till August, and it's likely actually to be towards the back end of that. So that's not controlled by us, that's controlled by SpaceX. Certainly by the end of August, we'll have an announcement out about the demonstrator satellite that's going up. So that will have the first terrestrial data center grade GPUs in space, so about 100 times more powerful GPUs than are currently in orbit. So yeah, that will be a big milestone. We'll be the first to train a model in space, the first to run high-powered inference, first to do fine-tuning of a model in space. Lots of firsts are coming up on that mission. And as you say, it's about the size of a fridge. It's like 50 kilogram or 65 kilogram with payload. Small sat. And then next year we've got the second one going up. But just to finish on your point on total energy consumption, there comes a point, and we see that as around 100 times the current data center capacity, terrestrial data center capacity, where even if you solve the energy problem terrestrially, let's say nuclear fusion works, just the heat alone that these data centers are kicking off is enough to cause very significant problems in terms of global warming. And it's not global warming from carbon dioxide that's going out, it's global warming literally from trying to cool all of these chips. So most data centers are using fresh water to pump out steam. That's how they cool them. Well, number one, water vapor is actually a pretty good greenhouse gas itself. But number two, you're literally just pushing heat into the atmosphere that will have a much worse warming effect than anything that is being caused by fossil fuels. So at some point and that's only with 100x. We could be talking about 1,000x or 10,000x increase over the next 100 years. So at some point in the next 100 years, you do need to figure out how to dissipate all that heat into the vacuum of deep space. So you do need to have these things on satellites with large deployable radiators dissipating the heat in infrared into deep space. Otherwise, you're literally just making the planet uninhabitable by the heat from sensors.
That's fascinating. And I think part of why when I first, like I said, I can't remember when or where I came across, I think the white paper, what have you, I was just blown away because maybe subconsciously it just makes perfect sense that with this level of change and movement in the direction of, where we're all headed, this is a massive challenge and opportunity. And tell me, and you know, if there's any of this you can't share, totally get it. But tell us a little bit about what are you looking to test with that first launch? Like I think I read something about, well, I'm not going to steal your thunder, but go ahead and tell us a little bit about like what you're comfortable sharing. What are you testing with that first launch coming up in that, you know, May to August period?
Yeah, so it's really just to say, can we operate data center grade terrestrial GPUs in space? And that means, does our thermal management system allow us to do that? Does our radiation shielding techniques allow us to do that? Can the chips survive vibration, the vibration of launch? So we've done as much of this testing as we can on the ground. So we've put it on these huge vibration tables and we've shook the shit out of it, as my co-founder says.
Nice. But you got to try, you got to test it for real, right? You got to get it over there and put it up in outer space.
We've tested it on every frequency in every mode at 10 times what we're expecting it to experience on launch. So I think I would be very surprised if it failed because of a vibration error, but cause of failure. But then, yeah, things like radiation are a bit more tricky because you have these like cosmic rays coming from the sun at very high velocity. You can kind of simulate that in a chamber, but it's a bit more tricky. So that's really what we're testing is, have we developed technology that allows us to operate terrestrial data center grade GPUs in space?
Okay, awesome. And I don't want to jinx you, and I promise you I'm not. Let's assume it goes okay, right? Take us a couple clicks down the highway, you know, for Starcloud. And I think I might have mentioned this. I'm so curious, like, what does not to be the Nerdville business guy, but what's the ICP, right? Like, what does the client profile look like? Who would you be approaching first? How does this work?
Yeah, so there's two very distinct phases of business. The first is offering edge compute workloads for other spacecraft, particularly Earth observation satellites and military and others. The second is competing directly with data centers, terrestrial data centers on energy cost. And the second is very dependent on launch cost, and the first is very not dependent on launch cost. So we can do the first business with the current launch cost, essentially. The second business will rely on launch costs coming down fairly significantly. So the first is, I mean, we're running various customer workloads on the first one with particularly, I can't say the names, but particularly government and military customers who want to run an edge compute workload. And so, for example, let's say you are an Earth observation customer of some sort. Maybe you're monitoring a patch of water and you want to see if there's a ship going through that patch of water. So what they do right now is they're collecting enormous amounts of raw imagery. They then wait for a ground station, they downlink all of that imagery, and then they run an inference workload on that in a data center on the ground. The problem with that is it takes, you have huge constraints on the amount of data you can downlink. So maybe you're collecting a few gigabytes of data a second from your imagery, but when you're above a ground station, you can only get off 500 megabit a second data rate, and you're only above a ground station for 5 minutes of every 90-minute orbit. So you have to wait potentially an hour before you can even get the data. With what we're doing, they can send all of that data to us with an optical terminal in space. We then run the inference on that in space, and then we just downlink the insight. And the insight's a very low packet. It might be less than a kilobyte. It could just be, yes, there's a ship in this location moving in this direction, which is obviously much easier or much less data rate to downlink than all of that raw imagery. So that's the first customer profile. It's basically people who want compute on orbit. There's a few other like higher value terrestrial use cases for things like that. Crypto people, not only the dodgy ones, like the legit ones too. For redundancy mainly, like people want to store keys on orbit, they want to run nodes or other things. And in the end case, when we have cheap energy, they'll want to do mining in space as well. The second, once the launch cost hits a certain point, we expect our energy cost to be significantly cheaper than terrestrial energy prices. And at that point, we'll be competing with, you can think of it a bit like a CoreWeave or a Lambda. I don't know if you know those guys. So they sell compute time to the hyperscalers like Microsoft and AWS. That's the sort of end business model, is selling compute time to those kind of guys.
Absolutely fascinating. And then another kind of a random question, but you kind of walked us through the origin and whatnot, and the origin story. I would be so curious, what kind of challenges have you faced with people saying, hey, Philip, it's not going to work, here's why. Hey, this is a bad idea, here's why. And how much of those kind of objections or challenging, statements have they changed? And what do you anticipate go forward? Because it sounds like you're getting to a place where you're going to have some data off the back of this launch that's going to be quite compelling. So I'm just curious what that kind of experience has been like and how you anticipate it's going to evolve.
When we did the launch, to be perfectly honest, we got quite abused on X. I don't know if you
Did you really?
Yeah, if you go back through the comments, oh my gosh, yeah,
X is brutal. I mean,
yeah,
it's the wild west.
X is definitely the worst one. And LinkedIn people were very happy about it. On X, people were
LinkedIn is very civilized. I mean, I love it, but listen, you got to put your hard hat on when you go in there. You know?
yeah. No, we got pilloried. But I'm not sure exactly. I think people find it hard to imagine a world with extremely low cost launch and extremely high capacity launch. I think people are very stuck in a world where, for example, the ISS costs $100 billion, and people think, oh my God, if you have to spend $100 billion to put your data center in space, this is obviously the dumbest idea in the world. It's like, yes, it is obviously the dumbest idea in the world if you have to spend that. But with one Starship launch, you could launch the entire ISS for $10 million. So instead of $100 billion, you can launch it for $10 million. So, I mean, we maybe like 2 Starship launches, but like we're heading to a world where the launch cost is insignificant compared to everything else. And I think people just have a hard time getting their heads around that. I mean, yes, space is hard. Yes, we have to figure out the cooling challenge. We're building an enormous radiator. Yes, we have to figure out radiation and other things. But all of that, nothing is against the laws of physics. You just have to be really dedicated and put, and we've got the best space engineers in the world working on it. We've just hired a guy from NASA's JPL who worked on the radiation or the radiators for the Europa Clipper mission. We've got 2 guys from SpaceX who've been there for 4 years working on various things. Guy from Azure doing the GPUs. My co-founder Addy was at SpaceX and also 20 years on the data center side. So if the team we've got can't figure it out, then nobody can figure it out. But I'm confident we'll get something good work.
I'm sure you will. And I've got another question, because I know, so a lot of my audience is either super technical or the other side of the equation, but I think everybody's fascinated with space. And so as someone who operates more or less in that environment, literally and figuratively, tell us a little bit more about some interesting stories or interesting things that you've learned about this idea. Like, I'm just fascinated by the idea of launching anything up into space that can become part of industry and all the growth that could result from that. But that's just my kind of business mind. But I'm curious, just as someone who operates day to day in this world, like, what are some kind of interesting things you've learned, stories, anything? Go for it.
I mean, yeah, I think that I find it interesting the range of other applications there are going to be with low cost launch. Like, I didn't realize that asteroid mining was going to be a thing until quite recently. I mean, I've heard the concepts and it always sounds far-fetched, but until recently I started looking at it, I was like, I mean, if low-cost launch is going to be a thing, asteroid mining is definitely going to be a thing. Same with manufacturing space, same with tourism, space hotels, like it's definitely going to be a thing. All right, I'll tell you some cool stuff.
Here we go. It better not be about White Lotus, because I'm not watching.
Well, indirectly.
There we go.
It's about very luxury hotels on the moon. White Lotus is about very luxury hotels. For the listeners, I was encouraging Alec to watch White Lotus earlier.
Resisting, but I'm going to try.
I've been scouting various sites on the lunar surface for an expensive hotel, and there's some cool places where you would land. It would be lunar sunrise, and lunar sunrise takes about 3 days, and then you'd have the Earth rise, sorry. So you'd land, you'd be on the side of a crater. It would be permanent sun, and then you'd have Earth on the horizon. And you could build this infinity pool. And then what you could do, when you're swimming on the moon, so the whole thing would be in like a dome, in like a pressurized dome. If you're swimming on the moon, you could basically swim like a dolphin, so you can propel yourself out of the water. And you could do the reverse of a dive. Like, you could propel yourself so far out of the water, you could land on a diving board. Anyway, yeah, you could basically swim like a dolphin on the edge of a crater with Earthrise in the background, 24/7 sunlight, sipping a glass of Veuve Clicquot.
I'm not... That sounds absolutely amazing, and I was hoping for a story like that. I will absolutely start watching a little White Lotus if I get an invitation to your luxurious future hotel on the moon. And Philip, I absolutely appreciate this and the time, and I know you got a million and one things to do. Is there anything else you'd like to share with the audience and what have you about Starcloud, or anything in general? Again, I really appreciate your time.
Yeah, no, I'm very happy to be on. No, I think that's it. Yeah, nothing on top of my mind.
All right. Well, I'm gonna keep an eye out for all things StarCloud and dolphins too, because I love dolphins, and we'll have to do this again. But Philip, I really appreciate it. I hope everybody looks into StarCloud, and I'll see you out there on X, and we'll make sure that all those tough critics learn more and more about this and become fans.
Appreciate it.
All right, man.